Hi students. So we discussed about many scheduling algorithms. So one more algorithm we want to discuss, that is scan disk scheduling algorithm. So scan, it will want to scan all the sectors. Sorry, not all the sectors. Basically sectors, but it will want to scan all the cylinders basically. Okay, that is the reason why scan. For example, in railway station, what they will want to sweepers will want to sweep one side, right? Yes or no? So like that, it will going to scan everything. So from one side to another side like that. Okay. I will give you the example. Don't worry about this. Okay. As the name suggests, so according to the name, a scan disk algorithm, scan disk scheduling algorithm. This algorithm scans all the cylinders of the disk back and forth, nothing but what, so it has to move towards the forward. Okay, so when it starts from particular point, it is going to move towards the forward by forward, how I will tell you, so by increasing the numbers. Okay, so like that. Okay. I will show you that control by, it starts from one end of the disk. That's what I told you, the pointing head point. Okay, head point, what it will going to do, it will going to start from particular end. Okay, so particular end start from one end of the disk. Okay, and move towards the other end. So like this, if you want, I will show you later. I will show you that one towards the other end, serving all the requests in between. Okay, I will tell you that one. Don't worry. After reaching the other end, the head reverse. Nothing but when reaches, when you see the railway track at all. So for example, I will write here. Don't worry. How I will tell you. Mm, sorry. See, let's take railway track is there. Railway station look like this. Yes or no? Okay, this is the platform. Railway station. When you enter into the railway station like this, okay, this is your starting point. What happens here? So the sweeper will going to start from here. He will going to move here, like that. He will going to complete this region first. After that, he will come back. He will come back here. Again, he starts from here. Again, he starts from here. He will going to complete from here. So like that, this algorithm will going to do. So that's what I'm telling you. In the railway station, when the sleeper starts from here, so he will going to complete up to here at the end. Okay, totally at the end. After that, he will start. He will come back. Nothing but reverse. He will going to do the reverse from here to here. Again, he will going to start from this point. Again, he will going to complete at this point. Nothing but ending point. Nothing but he is covering all the direction. Yes or not? He is covering all the platform. So when it comes to the second section, he is covering this one. So first section he covered all this, half of this. Again, second section he covered this. So it is based on depends upon the point, the entry point. Okay, so we will discuss about this one. We will discuss. After reaching the other end, the head reverse its direction. What I told you else before, this one. Okay, you can see this one. This is the one. Okay, reverse direction and move towards the starting end, serving all the requests in between. Okay, the same process will going to repeat here. Same thing. Okay, no, don't worry about this one. So we'll go to the next one. Okay. So notice what very simple. What they are saying about the note here is, so this algorithm also will call it as elevator. You can able to see the elevator like this example I will tell you. Don't worry. So what is this elevator will going to do? See, suppose think like that. This is the elevator. Okay. So people can come inside, right? Nothing but lift I am talking about. Elevator is lift. Okay, see here. So people can come inside. Things like that. There are a number of floors are there. From start from 0 to something like 10. You take it. So at the 10th floor you are there. When you press the button, okay. So what happens here? So it will move on keeping up to last one. Yes or not? Okay. When you press the button for ground floor or 0th floor, up to here it will go to serve. Suppose if the elevator is starting from here, so when you press this button, any button, so when you press the 10th floor, automatically it will not go to the 0th floor, it will go to directly 10th floor. Okay. After the 10th floor, so somebody comes in, again they will want to press 0, again it will come back here. Okay. So like that it will go to serve. Yes or not? So that is the reason why it is called as elevator algorithm. Basically it is an elevator algorithm. Okay, fine. I think you people are very clear about this one. So I will clear this one. I will follow. I will go a little bit further. So scan algorithm is also called as elevator algorithm. This is because it working resembles as a working of an elevator. As like working of elevator, just I showed you that like that it will going to work. That's it. Advantage is very simple, easy to understand, very easy to implement. Again, it does not lead to starvation. Is nothing but waiting. Okay, whatever the entry comes or track comes or whatever the input request arrives into the operating system, there is no starvation, nothing, no waiting, nothing. It provides low variance in response time and varying time. Now, low variance is nothing but the cycle time is going to be reduced here. That is the only reason. That's what they are saying very clearly. So, low variance time in response time and waiting time. That's it. So we'll go to the next one. So disadvantage is it causes long waiting time. Why it is causes long waiting time? Because see, if you go to 10th floor, again you want to come to first floor, right? So that time it will take a lot of time. That's the reason why if, long waiting time for the cylinder just visited by the head. Okay, that is one problem over here. It causes the head to move till it causes the head to move till the end of the disk, even if there are no requests to be served. So why they are saying like this? Because say in the platform, we have taken an example here also. What happens here? If there is no at the end point, if there is no request, even though it will go up to the end point. That is one kind of disadvantage here. Because so when it moves up to the end point, automatically what happens here? So automatically the system is going to increase. This then read and write response increases. Okay, so we have a small problem. We will practice the problem based on scan disk scheduling algorithm. So you can see this. So we'll see the problem. Problem is like this. I will write. I will read. Consider a disk queue with the request and one input output request. Put blocks on the cylinder is with the cylinders 98, 183, 41, 122, 114, 124, 65, 67. The scan scheduling algorithm is used. The end is initially at the point 53. Okay, moving towards the largest cylinder numbers observed in the past. The cylinders are numbered from 0 to 199. Why? Because it's an array. Okay. So check what we have to identify. As like that, we have to identify total number of 8 moments. So that's what we have to identify here. That's you're going to see. So solution, how it will be. So initial point is let me write. If you want, I will going to write. See, solution looks like this. Okay, so solution will be like this. No need to worry. So we have seen that 53 our initial number. Yes or not? 53 is our initial number. So what is the seek time? We have to check with the seek time. Okay. First, it will move towards forward. Okay, forward it will want to move towards forward. How I will going to tell you that one. Okay. First, it will want to check 53. So that is the starting point. Again, it will move either forward or backward. It is up to algorithm choice. Okay, it is moving towards. Okay, first it will move to 65. Again, it will move to 67. Again, it will move to 98. Again, it will move to 122. Again, it will move to 124, 183. See this one is very very important. So based on the algorithm, scan algorithm, what happens here? One side it will want to scan. So that's what it is. Whatever the points are coming into the track on the platter, everything will be scanned one side up to last track. That is 199. That is the last track. From here up to it will go to scan. So what is the next request we have? You can able to see here. See in this previous problem, you can able to see 98, 183, 41, 122, 14, 124, 65, 67. So we have to take one particular direction. Okay, so based on the direction, we will going to clear one part. So you have to take the example of railway station. You have to complete the one side of scan. After that, you have to come back again. You have to start that. So where you started from that, you have to take the points. Nothing but cylinders you have to serve. Okay, see here, according to this problem, input output request. So what happens here? We have served all those things. So after that, 53, we have few things, that is 41 and 14. We have to serve these two. So that is the reason why. Again, algorithm initially started here, yes or not? Okay, it moves here. again 65, again moves here 67, again moves here 98, again moves here 122, again moves here 124, again moves here 183, again moves here 199. That is the end point of the track. So again it has to scan some more time. It has to scan some more points which are given in the input output request. So that's why immediately it will come to the that particular point, that is 41. You can able to see here up to here we scan. See this up to here we scan. Yes or not? Up to here we scan here. Okay, then after that we have a point that is 41. It will come to the 41. Again, one more point we have, that is 14. So after that we don't have any request. That is the reason why it will going to terminate over there. So the total head movements include while serving this request we have to calculate. That when you calculate this one, already I told you you can calculate like this: 199 minus 53, again 199 minus 14. So otherwise you can calculate 65 minus 53, 67 minus 55, 98 minus 67, 122 minus 98, 124 minus 122, 183 minus 124, 199 minus 183, again 199 minus 41, 41 minus 14, like this, like that. So that is an alternative way you can able to calculate that one. There is no problem with that. Okay, fine. So I will take see, that is the way you can calculate. This is the way. Otherwise, alternative way I told you, right? So you follow this one. So like this, you will calculate. Total head moment is over here in the scan algorithm is 331. I think you understood. Yes or not? So here, so this is all about scan algorithm. We're going to see the one more algorithm, that is C scan disk scheduling algorithm. So in this algorithm, it's very simple compared to the scan and the scan. Both are equal only, but little bit changes there. No need to worry. I will explain. Circular scan algorithm is an important version of a scan algorithm. Told you, right? Very important. So this one. So based on that only, it will go to happen. Okay, scan algorithm based on the scan algorithm. So it starts from one end. Basically, I told you, right? So I will going to write again. I will going to explain. So see, basically it's from start from particular point like this. So it starts from particular point, one end of the disk, and move towards the other end, serving all the requests in between. So what happens here? Suppose in between whatever the requests are, every request will be served here like this. It will want to serve. After that, what happens is, reaching the other end, it reverses its direction. Nothing but okay. So think like that, a railway station, take it as a railway direction. So starting at here, what happens from here to here, it will go to move. Again, immediately it will come back to the end point here. So it will complete here. The sweeper completes here. Again, the sweeper, what happens? What it will do? It will come to the end point of the next part of the platform. Okay, so you will going to start from here. So the this people come to here. Again, you will going to start from here to here. Again, is start from up to here. So like that, it will going to happen. So that one I will show you. Don't worry, no need to worry. Okay, fine. It starts from one end of the disk. This is over, right? Okay. So then it returns to the other starting end without serving any request in between. That's what I told you. So it will not going to serve any request in between the starting point to the next end point. But what happens here, it will going to come back to the initial point which is not served. Nothing but initial point of the last point. Okay, so this process will going to continue. Okay, we will going to see what are the things will going to happen here. So, let me take okay, we'll go to the next slide. No problem. See, so we have an advantage and disadvantages. So same thing, you can able to use this. The waiting time for the cylinders just visited by the head is reduced as compared to the scan algorithm. Compared to scan algorithm, so whatever things we visited, that will be reduced. Nothing but nodes. Whatever the nodes we visited, so no need to visit the node once again. Okay, directly it come back to the initial point of that particular disk. Okay, it provides an uniform waiting time. So nothing but uniformity will going to happen in the waiting time. Provides a better response time. So whatever the read and write things will going to happen on the platter, that will be response very well. So that's my better response time. Okay, again come back to the disk. Let's see the disk. So disadvantage, when it comes to the disadvantage, it causes more seek moments. Nothing but head moments are becomes very high compared to the scan algorithm. So like this, it will come from year to year first. Again, it will come back. So let's take this one, this point as a starting point. From it will going to start from year to year. Again, it will come back to the other end year. Again, it will going to start from year. Like this is not. I will going to write like this. No problem. I'm going to write it. I'm going to explain. Right. So let's take like this. Suppose. It will be what I do. See, suppose think like that. This is the initial point. You take it as. So when it starts, when the it starts moving, it starts from like this. It will going to move up to the hand. Okay. Again, after completing the hand, again it will come back to the one more initial point, that is the end point. It will come to the end point again without meeting any node points over here which are meted ends before. Again, it will going to start serving the points from here like this. So it will going to complete here. So nothing but what happens, the seek time. Okay, so moments, seek moments compared to the scan algorithm increases. See, so it comes to here. Again, it go back here. Again, it is coming back here. But when you see the scan algorithm, so what happens? It will come to the end. Again, it will come back. Again, it start from here to serve. So here it will going to start here, here, here. It will going to. So you will not going to find this one in the scan algorithm. That is one of the big advantage in the scan algorithm. Okay, I think it's clear, right? So now we're going to explain further what is there in that all those things related to C scan. So it causes the head movement till the end of the disk. That's what I told you. So if there are no requests to be served, so if there is no request, definitely it will be no problem. So we'll go to this one. So problem, you can see the problem. So these are the track numbers which is requested by input output to the operating system. So you have to see the starting cylinder, that is 53. This is the one 53. So starting cylinder you need to identify. Always that is very important where you start. That is very important. So the starting point is 53. These are the tracks you need to visit. Again, cylinders 0 to 199, nothing but totally 200 cylinders are there. What you want to calculate? The total at moment you need to calculate. So calculate this one. So number of cylinders using cylinders, we will see that one. Solution, you can see the solution. So if you want the solutions looks like, means before I want to write, so that it will be helpful to you. So I will write the solution, don't worry. So here, so what happens here, I will tell you, see, let's take like this. So like this. So somewhere you will going to find the 53 point in this is thing like 53. Okay. So after that, what happens? It will going to start from. So if you go to the back, if you go back to that number cylinders. So what happens here? It will going to start from here. It will move like this, move like this. This is basically, sorry, this is basically endpoint. Yes or not? This is basically endpoint. This is the one endpoint. So up to here, it will going to meet. Okay. After that, immediately it will come back to this endpoint like this. Again, it starts serving those requests which are requested by input output to the operating system. Again, it will going to stop here like this. You can able to see the solution. I will want to show the solution. Let me clear this one. So you have a little bit time in between. You can able to pause it and you can able to solve this one. That's why I made a blank space for you people. So please solve it. We will get to know how it will going to work. So we'll want to see the solution. Let's see. Yeah, done. Bang. Okay, so now we can able to see the solution. See, the starting point is 53. It will going to solve the point moving forward 63, 65, sorry, 67, 98, 122, 124, 183, 199 like this. 53, 65, 67, 98, 122, 124, 183, 199. Again, immediately what happens basically when you see the this which one scan algorithm, it will come back to the initial point which is with the it is started. Again it starts serving 41 14 like that, but it is not like that. It will going to move all the dead end of the track of the cylinders available on the platters. Again it will come back to the dead point, nothing but end point of the track, which is started the stacks for starts from 0 to 199. So it will come back to the zeroth track from the track it starts serving the points, that is 14. You can able to see nothing but the increase of edge moment is increased here. Otherwise, if you take the scan algorithm, so the edge moment will going to be decreased because that will be served here only, that is 41 after that 14. But when it's come to the C scan, so immediately it will come back to the initial track, that is 0. Again it starts serving the request, that is 40. Again you'll want to serve the 41. So how you want to calculate, as I told you before, like that you'll want to calculate 41 minus 40. After that 199 minus 40. Okay, after that we take it as 199 minus 53. Like this also you can able to calculate. Otherwise 65 minus 53, 67 minus 65. That is also one kind of method you can able to follow this one. Follow that one. Okay, fine. So you can able to see this one alternative method I already mentioned. So this is how you want to calculate. This is how about 6 algorithm. Very simple. When it comes to the scan algorithm and C scan algorithm. Scan algorithm initially it will start at the particular end. I am going to show you those things. See. Okay, in the scan algorithm. So let's go to the problem. Okay. Sorry, sorry. So this is our scan algorithm. Yes or not? This is our scan algorithm. So what happens here? So it will going to start from here. Again, it will move to the up to dead end. After that, it will come back. See, after coming back, so it starts serving the nearest cylinder. So 41 and 14. So when you see this diagram, you can understand the moment of head movement will going to be very less compared to the C scan. But when it comes to the C scan, so when it comes to the C scan is nothing but circular scan. Okay, circular scan is algorithm. So here, when it completes this one up to the dead point of the cylinder, that is 199. Again, it will come back to the initial point of the cylinder, that is 0. Again, it will start serving that number, that nodes you can able to see up to here. Whatever the nodes are available, it will going to start from here. So that's why it is going to increase the head moment. That's why sig time will going to increase. So both are very good algorithms. You can put it as wherever you want it. Okay, so this is all about algorithms related to C scan and scan algorithm. Scan and C scan. Okay, thank you.